So for section 6.2, we're going to be looking at graphing sinusoidal functions. So we're going to be graphing sine of theta and graphing cos of theta and seeing what those graphs look like. So first, what I would do is pause the video and fill out this table of values and then hit play and see if your answers match mine. So fill this out in pencil, let's say. So what you would do is take the sine of theta, and if theta is negative 360 degrees, take the sine of negative 360 equals, and for example, you should get for that one 0. And for example, the sine of negative 270 degrees, you should get an answer of 1. So pause the video, do all these. So this is just continuous. After the negative 30 here, 0 and 30 degrees would be beside it and continue going. It's just that there's not enough room on the page. So this is just continuous from negative 360 degrees to positive 360 degrees. Okay? So pause it and come back so that you know how to fill out the chart. Okay, so hopefully your chart matches mine. So again, you can pause it and double check your answers according to mine. So using this table of values, right? So this would be your X value. So we need X to go from negative 360 to positive 360 along the X axis. And our Y value goes as low as negative 1 and all the way up to positive 1. So this would be what the sine of theta looks like. So use your table of values to graph sine of theta. Use increments of 30 degrees for the x-axis. So you can kind of see here that for some reason this line here has disappeared on me because I have 5 lines positive on the y-axis, 1, 2, 3, 4, 5, and here I only have 1, 2, 3. Oh, I do have 5. 1, 2, 3, 4, 5. So I don't know why there's that extra spacing there. So I want to go in increments of 30 degrees on the x-axis. So for example, this would be 30, 60, 90, keep going up by 30, 120, 150, 180, 210, 240, 270, 300, 330, and then 360 would be 1, 2, 3, 1, 2, 3 away from the end. And then here, I think I'm going to add in a line because otherwise our graph is going to look off. So if we add in a line here that was missing. Okay, and we want to go up by increments of 0.25 for the y-axis. So if this is my 0, 0 here, right, my origin, so 0.25, 0.5, 0.75, and 1, 1.25, 1.5, for example, and then negative as well. Negative 0.25, negative 0.5, negative 0.75, negative 1, And we want to go to the left side of the x-axis as well. So this would be negative 30, right? Negative 60, negative 90, 120, negative 150, 180. Now I'm just writing out every other one. Negative 210, 180, 210, 240, 270 is this line, just making sure I'm not skipping any lines. 300, 330, and then 360 is again 1, 2, 3 away from the end, the same as before. So if I graph it, I'm going to have a dot at 0 and 360. That's one coordinate point. And then at 330 and 0.5, so 330 and 0.5. And then 300 and 0.9. So 300 is here and 0.9 will be close to the 1 above 0.75. And then negative 270 and 1. So negative 270 and 1. And back to the same place on the other side, the negative 240 and 0.9. Negative 210 and 0.5. Just reading this off the graph. And then back to negative 180, which is this one, and 0 on the y-axis. And then I'm going down to negative 150 and 0.5. Negative 120 and negative 0.9. Negative 90 and negative 1. And then back the mirror image, negative 60, negative 0.9, negative 30, and negative 0.5, and 0 and 0. And then I'm going to continue 30 and 0.5, 30 degrees, 60 and 0.9, 90 degrees and 1, 120, 0.9, 180, 150, sorry, 0.5, 180 is at 0, 180, comma 0 as a coordinate point, let's say. And then 210 and 0.5, 240 and 0.9, 270, right, was at 1, 300 and 0.9, 330 and 0.5, and then 360 and 0. So this is the x-axis here, right? This is theta. So then let me get a thicker line here. Okay. I'll try my best to draw a straight curve through here. Not straight meaning straight line, I just mean, can I join the dots together? So this is what the graph of the sine curve looks like. Sine of theta looks like this. So some properties of it is it goes across the x-axis at 0 degrees, 180 degrees, 360 degrees, negative 180 degrees, and negative 360 degrees. So that's, I don't know if I can erase that close. Yeah. Is there an undo here? And if we look, the peak value that we talked about for the y value would be 1, right? Peak value is 1. The troughs are at negative 1. And the exact middle of the graph would be along this x-axis. So that equation would be y equals 0, right? So state the domain and range here. So the domain, if we continued this, it would be going on forever to the left and going on forever to the right. So for the domain, we have D for domain belonging to D is equal to theta belongs to the set of real numbers. Sorry, I have to make my, and then that's it. It's going on to the right and to the left forever, right? So what about the range? The y values. Again, it's a continuous line. So for the range, y is going to belong to a set of real numbers, but we do have restrictions here. Y isn't going any less than -1 or any greater than 1. So y is greater than or equal to -1 and less than or equal to, because it does equal 1. So you can put the greater than and less than or equal to. Okay, let's make this less thick. Okay, so just trying to get what the other questions are, and I'll try to answer them without erasing this. So down below that, it says highlight one cycle. So again, one cycle would be like one period. So if I want to highlight one cycle, let's go here and change our, let's make it yellow. So one cycle, and make it thick again. Let's say we start here, right? One cycle would be up to the trough, up to the peak, sorry, down to the trough, and back again. And now it would repeat itself, right? It would be the exact same. If you took a piece of paper here, cut this piece off, and put this part of the graph on top of this part of the graph where you can see through the paper, they would be directly on top of each other. So that is one cycle of the sine of theta graph. State the following for sine of theta. What is the period? So again, the period is how long it takes it to duplicate itself, to run through one cycle. So from 360 to 0, so the period, so 5a is down below. I'm just going to put it here. And the answer to 5a is 360 degrees. Okay. B, what is the maximum and minimum value of which are the y values? So B, the maximum value is 1, right? The maximum value is 1, which is at the peak. The minimum value is -1. So you're always looking at your y values, right, for max and min, which was the same for parabolas. And that occurs at the troughs at -1. So what is the equation of the axis of the curve? So we already said that we know that just by looking at it here, this would be the exact middle of the graph, which should be y equals 0. But again, the formula for that is y equals the max plus the min divided by 2. So 1 plus -1, which 1 plus -1 is just 0, right? 0 divided by 2 is 0. So we have the equation y equals 0. And I'm just going to change my colors so you can see this better. And then for part D, what is the amplitude? So the amplitude is, again, from the equation of the axis to, so from this equation of the axis to the peak, this is my amplitude. And from the equation of the axis right here, let's say, to the trough, right? So I could also say it's from -1 to 0. I can take a look, it's from 0 to 1. So I'm also looking at my y's, right? So my amplitude, though, mathematically would be equal to the max value minus the min value divided by 2. So the max value is 1, subtract the min is -1. So I actually have 1 plus 1 was delayed. So 2 divided by 2 is equal to, that's why. All right. is equal to 1. So the amplitude is 1, and I can see on here from 0 to 1, it's got a height of 1, or a radius of a circle of 1. From 0 to -1, it has a height of 1. Okay, so next we're going to complete the table of values and take a look at what the sine curve, take a look at what the cos curve looks like. So same thing here, take a second ahead of me. So we just answered all these questions here. So let's take a look at what the cos of theta. So take negative 360 degrees cos. What's cos of negative 360 degrees? And so on for the chart. So pause it, fill it out, and then come back to it when you're done and see if your numbers match mine. Okay, so if you take a look, if you get cos of negative 360 degrees, you should get 1. Cos of, for example, negative 300, you should have 0.5. Cos of negative 270 is 0. Cos of negative 180 is negative 1. Cos of negative 90 is 0. Cos of negative 30 is 0.9. Just for example, cos of 90 is 0. Cos of positive 180, is negative 1. Cos of 270 is 0. Cos of 360 is 1. So if we take this again, with cos of theta being the x-axis and our values here being the y-axis, and same thing as before, use increments of 30 and use increments of 0.25. So again, I'm going to move this up. We'll take a look at what's different, because obviously it's not exactly the same. It's going to look similar. So we have to draw in our values. So again, if I could, no, I'll put it in the same spot. Let's make this 0, 0, so it looks exactly the same as the graph before. So this is theta, this is y, and then go by 30, right? 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360 is again 1, 2, 3 away from the end, the same as before. Negative 30, negative 60, negative 90, negative 120, negative 150, just keep going by 30, negative 180, negative 210, negative 240, negative 270, negative 300, negative 330, negative 360. And again, it's 1, 2, 3 away from the end. And if I go up by 0.25, so 0.25, this would be 0.5, 1, and 1.5 at the top. So if this is my, again, 0, my origin, negative a quarter, negative 0.5, and negative 1 is second up from the bottom. and then get my table of values. So I actually have at 0 on x, I actually have a value of 1. Sine of 0 or cos of 0 is 1. And then cos of negative 30 is 0.9, and 30 is 0.9, and 60 is 0.5, negative 60 is 0.5, 90 is 0, 90 is 0, and then at 120, I'm at negative 0.5. So at negative 120, I'm at negative 0.5. Negative 150, I'm at the negative 0.9. And negative 180 is negative 1. And here negative 240 and negative 0.5. And then 270 is where I get back to 0. And then negative 300 is at positive 0.5. And negative 330 is at 0.9. And negative 360 gets me back up to 1. Same on the other side, I was at 150. So 150 is at negative 0.9. And then positive 180 is negative 1, which is the same as negative 180. The positive 180 will be in the same place at negative 1. And then 210, 0.9. And then 240 at negative 0.5. And then 270 at 0. 300 at 0.5. 330 at 0.9, and 360 again brings me back to 1, just like negative 360 is bringing me to 1. Now again, let's see how well you can do a curve through there. It's not so easy. It's harder on a computer, right? So let's see here. Join the dots together. And it would be easier on paper, trust me. On this tablet, and I'm not going super slow. I don't want you to watch me draw this for 5 whole minutes here. All right, and let's answer the same questions that we answered about the sine curve. So this is the cos curve. So the difference is sine started at, let's say, at the origin 0, 0, and cos is starting at 0 and 1. But other than that, the peaks are at 1, the troughs are at negative 1. The span is the same. My equation of the axis, the middle of the graph is still along the x-axis here. So the equation would be y equals 0, but we'll go through that again. So let's answer what the domain and range would be. So the domain again is the same thing. The x values here would go forever to the right and forever to the left. So for the domain, we have theta representing all the real numbers. The range, y belongs to the set of real numbers, but we have the same restrictions that we had on sine, where y is going to be greater than or equal to negative 1 and less than or equal to 1. Highlight one cycle of cos of theta. So one cycle here, let me change my color. Yellow, make it thicker again, see if that works. And let's try this again, covering up. One cycle, it's starting here at 1. It's going down in the trough to negative 1, and it's coming back up. And then at 1 here, it's going to repeat itself. It would be like drawing out the same thing. So that would be one cycle. And then state the following for cos of theta. State the period. So that would be part A here. So again, the length of one cycle starts at 360 and ends at 0. So the period would be 360 degrees, right? Before it repeats itself. What are the maximum and minimum values? Which again, I'm looking at y. The maximum value, which is the peak, is 1. The minimum value, which is the trough, is -1, right? What is the equation of the axis of the curve? So again, the line that would directly split the graph in half here would be right at y equals 0. But again, you get that by max plus min divided by 2, right? So max is 1 plus min is -1 divided by 2 is again 0 divided by 2. So I have the equation y equals 0. Put d over here. What's the amplitude? The amplitude is looking at my axis of the curve equation, right? Looking along the x-axis here. It would be where I sit from there to the trough. So I can see it starts from 0 to -1. So that would be an amplitude of 1. And then from 0 up to +1. So that would be an amplitude of 1. But how do we get it? We could also do max minus min divided by 2, which ends up being 2 divided by 2. And I get 1. But I can also see it visually on the graph. What transformations could you apply to y equals sine of theta to obtain the graph of y equals cos of theta? So if we were to put, let's say, draw sine of theta and cos of theta on the same graph, so sine of theta would start at 0, 0, we would see that from sine of theta to cos of theta, it's shifting to the left 90 degrees. So here, these are the questions that I've already answered, where the period is 360, the max is 1, the minimum is -1, the equation of the axis is y equals 0, the amplitude, you could put A for amplitude. So for example here, right, for a final answer, instead of just 1, you can say A equals 1 for amplitude. So what transformations do I have to apply to sine to get the graph of cos? Because it looks exactly the same. It's just shifted to the left 90 degrees, or to the right 270 degrees. So a periodic function is a function whose graph repeats at regular intervals. So if you see the graph repeating regularly, then that would mean that it's periodic. What does sinusoidal mean? So a sinusoidal graph means that it's periodic, but it also looks like smooth, symmetrical waves. So symmetrical is important, right? Where any portion of the wave can be horizontally translated onto another portion of the curve. So what does that mean? So that means that symmetrical, I've got my drawing tool here. Symmetrical means if I was to draw a vertical line, right, there would be a reflection. Exactly what's on this side would be mirrored on this side, which is true. If this were to be my mirror and I were to draw a line through here, what's here is being mirrored on this side. And if you draw that line anywhere, right, then that's happening on both sides. It's a mirror image of each other. It's symmetrical on both sides. Also, the horizontally translated onto another portion of the curve, that just means, again, if you were to take a piece of paper and cut or rip this, if this whole thing was a piece of paper and you ripped it in half and took this piece and put it on top, they would line up with each other perfectly, right? So then what it says is the sine of theta and is the cos of theta periodic? And is it sinusoidal, or is it periodic, or is it one or not the other? So again, periodic means that the graph repeats at regular intervals. So I can see from the graph that it does repeat at regular intervals, right? It has that 360-degree period, and then it does the same thing over again for 360 degrees, and then it does the same thing over again for 360 degrees. So that means it's periodic. Sinusoidal would mean that it's symmetrical. So again, I'm looking at this, and if I were to look at the sine curve and the cos curve, if I were to draw a line, are both sides mirror images of each other? And they are, right? And if I were to cut the piece of paper in half or anywhere along it and I put it on top, would they match and line up with each other? And they do. So actually the sine of theta and the cos of theta graph are both. They're both periodic because they have intervals or cycles that happen regularly, and they're sinusoidal because they're symmetrical waves. And again, if you were to cut it in half, horizontally translated means if I were to shift it horizontally on top of another portion of the curve, they would line up with each other. So it's both. So for this homework, I would like you guys to do page 363 for 6.2, number 7, and number 14.